Now you see another theorem here. Modulus of the sum of two complex number is always less than or equal to the sum of their moduli. Or to show that the modulus of the sum of two complex number never exceed the sum of their moduli. That means we need to prove like this way. Modulus sum of two complex number and their modulus, yes, this is always less than equal to the sum of their moduli. This is we need to prove, right? Modulus of Z1 plus Z2 is always less than equal to modulus of Z1 plus modulus of Z2. This is we need to. There are many methods to prove this theorem. So here I will use one easy method here. So we consider here Z1 equal to R1 of cos theta 1 plus I of sin theta 1 and Z2 equal to R2 cos theta 2 plus I of sin of theta 2 B2 complex number, right? B2 complex number. We considered these two complex. So therefore, what will be the modulus of Z1? This will be R1 because this is the modulus. And here what will be? This will be the R2. This R2 is the modulus of this Z2, right? This is we get. Is it okay? Now, what will be Z1 plus Z2, guys? Just you try to find Z1 plus Z2 first. So just you try to take the sum of these two complex numbers. So what will be that value? I think this will be R1 cos theta 1, R2 cos theta 2 will be there, right? Here you see R1 cos theta 1, R2 cos theta 2. These are the real values. So you write like this way. Plus. Here you see I is present. Here also I is present. So if we take I common, then what we get? Sin theta 1 into R1 will get. So R1 sin of theta 1 plus from here I, if we take common, R2 sin theta 2, right? I2 sin of theta 2 will get. So here you see this is our Z1 plus Z2. This is the complex number. Again you see for this complex number, this is real part, this is the imaginary part, right? So what will be their argument? So what will be this argument of this complex number? Sorry, not argument, this is modulus. So what will be this value, right? You must remember the modulus of this one is nothing, root over of real part square plus imaginary part square, right? So this is modulus of this one square plus this one square. So here R1 cos theta 1, R2 cos theta 2. This real part square plus imaginary part square, right? R1 sin theta 1, R2 sin of theta 2 of square. Is it okay? So now you simplify this one. You use here a plus b whole square formula. So what we get? R1 square cos on theta 1 square plus R2 square cos of theta 2 square plus 2 of R1 R2 cos theta 1 cos theta 2 will be there, right? For this one. And plus this one square. That means from here also we get a plus b. If you use here a plus b whole square formula, then what we get? R1 square sin theta 1 square R2 square sin square theta 2, right? Plus twice of R1 R2 sin theta 1 sin of theta 2. This is we get. Is it okay? Now you see here from this one, this R1 square here common, so we can take common from here. Here R2 square we can take common, and from here we can easily take common R1 R2. So if we simplify this one, what we get? Here you see on the left side what is this one, right? And here if you take r1 square common, what we'll get here? Cos square theta 1 plus sin square theta 1. You see here, cos square theta 1 plus sin square theta 1. Similarly here r2 square, if we take common, r2 square of here cos theta 2 square sin of theta 2 square plus twice of r1 r2. If we take common here from here, this will be cos theta 1 theta 2, right? Cos of theta 1 theta 2 plus sin of theta 1 sin of theta 2, right? This will be the value. So from here, here r1 square, and you see this value will be 1, and here this will be r2 square plus twice of r1 r2, and this value will be rise here theta 1 minus of theta 2. Why? Because we have a trigonometric formula, cos of a minus b is nothing here cos a cos b plus sin a sin of b. This is the formula. So if we use this formula here, we will get this value. Now this value, guys, this value will be here less than equal to of root over of r1 square r2 square plus 2 r1 r2 into 1. Why? Because you see, the maximum value of this cos theta is less than and equal to 1, right? So since the maximum value of this cos theta is 1, so in place of this one, if you put here 1, then this value will be the maximum value of this one. So obviously this expression will be less than equal to this one. Is it okay? Because here we consider the maximum value of this one only. That means this expression will be either this one or less than this one. Is it okay? So from here, what will be the value? This will be r1 plus r2 of square, right? So square root will cancel. So finally what? Now what is r1? r1 is modulus of z1, r2 is modulus of z2, right? Here you see, this is r1 is modulus of z1, r2 is modulus of z2. So finally what we see here, modulus of their sum is less than equal to the sum of their modulus. Okay, this is our theorem we need to prove. Okay.